welcome to today's class. Today we shall deal with thermodynamics. In thermodynamics part, we deal with three laws of the thermodynamics: first law, second law, and third law, of which two are more significant, that is first law and the second law. And tomorrow we shall deal with the thermochemistry. After all, thermochemistry is the application of the first law of thermodynamics. Thermochemistry is nothing but application of the first law of thermodynamics. Now, what is the point to be remembered? Thermodynamics is the science developed based on the human experiences. Thermodynamics is the science developed based on the human experiences. Now, there are three laws of which two are significant. Thermodynamics mainly deals with the feasibility of a chemical process. Now, first law is nothing but law of conservation of energy. Energy can neither be created nor be destroyed. In first law, we deal with the quantities like W, work function, and delta E or delta U. What is this? Change in internal energy, delta H, and Q, and heat capacities, In the first law, we deal with mainly work and change in internal energy and change in enthalpy and amount of heat absorbed or evolved, and heat capacities. Heat capacities are of two types: heat capacity at constant pressure, molar heat capacity at constant pressure, molar heat capacity at constant volume. At a constant pressure, molar capacity is denoted as Cp, which will be equated to delta H. And what is the other heat capacity? At constant volume, heat capacity is represented by Cv. There are four mainly. How many processes are there? Isothermal process where delta T is equal to 0. Adiabatic process where Q value is equal to 0. Adiabatic process is also known as isoentropic process. Because in adiabatic process entropy change will be 0. And isobaric process. Now let us go for the expressions for work done during the isothermal process, isothermal reversible process. What is it? During the W is equal to minus nRT 2.303 log V2 by V1 during the expansion, or minus nRT 2.303 log log P1 by P2. This is the work done in isothermal reversible. In irreversible expansion, in irreversible work function, work done is equal to minus P external delta V, V2 minus V1. 1 liter atmosphere work done is equivalent to 101.3 joules, or 1 bar liter is equal to 100 joules. This is the two important relations which we have to remember. Now, in adiabatic expansions, what is the expression for the work done? In adiabatic process, Q is equal to 0. Therefore, W will be equal to delta E. Delta E will be equal to NCV dt. delta I is equal to NCV dt, but CV is equal to R by gamma minus 1, R by gamma minus 1. Therefore, W is equal to NR gamma minus 1 dt. So, it can be expanded as NR T2 minus T1 by gamma minus 1, which can be further written as P2 V2 minus P1 V1 by gamma minus 1, gamma minus 1. This is the expression for doing the work in the adiabatic process. Now, the second law mainly deals with entropy factor, entropy calculation of free energy change. So, second law of thermodynamics mainly deals with feasibility of a process, spontaneity of a process. What do you mean by spontaneous process? The process which take place on its own or by some proper initiation is called spontaneous. All naturally occurring spontaneous processes are irreversible, and for all natural spontaneous process, delta S total must be positive. Delta S total must be positive. What is delta S total? Delta S total is equal to delta S of the system plus delta S of the surroundings. How do you calculate delta S value? Delta S value in a chemical process is calculated as sigma of the entropies of the products minus sigma of the entropy of the reactants. In a phase transition process, for example, enthalpy delta S during the vaporization, is equal to delta H vaporization by boiling point. Delta S of fusion is equal to delta H of the fusion by temperature of the fusion. Now, what are the formulas to calculate the delta S value? Delta S is broadly taken as Q by T. What is Q? Delta E plus P delta V by T. But delta E is equal to NCV dt plus P delta V by T. So, expanding, delta S is equal to NCV dt by T plus what P can be written as P delta V. P can be written as nRT by V into delta V by T. T gets cancelled out. On integration, we get delta S is equal to NCV ln T2 by T1 plus NR ln V2 by V1 For an isothermal process, this can be expressed as NCV ln T2 by T1 plus NR ln in place of V2, because P1 V1 by T1 is equal to P2 V2 by T2. Therefore, V2 by V1 is equal to P1 T2 by T1. P1 T2 by T1. Rearranging it will become NCP ln T2 by T1 plus NR ln P1 by P2. ln P1 by P2. ln P1 by P2. These are the expressions for calculating the delta S values. Now, what is the necessary condition? Necessary condition for a spontaneous process, delta G must be negative or delta S total must be positive. These are the necessary conditions for the spontaneity of a process. Now, let us discuss the important concepts of the thermodynamics through the questions. Now, a system absorbs 600 joules of energy and does work equivalent to 400 joules of energy. The internal energy changes. What is the mathematical expression for the first law of the thermodynamics? For the first law of the thermodynamics, delta E is equal to Q plus W. Q plus W. Q takes a positive sign when heat is absorbed. Q takes negative sign when heat is given out. W takes a negative sign when work is done by the system, and W takes positive sign when work is done on the system. So, this is the mathematical expression for the first law of the thermodynamics. So, since it is absorption, Q takes a positive sign 600 and equivalent work is done by the system. So, W takes a negative sign for 600 minus 400, 200. We must be careful regarding the sign convention. Sign convention is very, very important. What is the mathematical expression of the first law? Delta E is equal to Q plus W. Q takes negative sign when heat is given out. Q takes positive sign when heat is absorbed. W takes negative sign when work is done by the system. W takes positive sign when work is done on the system. So, never get confused with the sign convention, which is most important in thermodynamics numericals. Next problem. During a process, work equivalent to work is done on the system. So, W takes positive sign, which gives out 125 joules of the energy. So, Q takes negative sign here. Q takes a negative sign here. What is Q? Minus 125. What is W? Plus 400. What is the change in the internal energy? 275. And what is the other important points we have to note? Delta E and delta H will take 0 in isothermal process. That will come later on. Next question. 1 liter atmosphere is approximately equal to 101.3 joules. So, it is approximately equal to 101 joules. 1 bar liter work is equivalent to 100 joules exactly. Next option. 1 mole of an ideal gas at 300 Kelvin is expanded isothermally from an initial volume of 1 liter to 10 liters. What is the delta E in all isothermal process? Remember, in all isothermal process, delta E and delta H will be 0, because in isothermal process temperature will be maintained constant. There shall be no increase in the internal energy or enthalpy. Why? Because the internal increase in the internal energy will be 0. H is equal to E plus PV. H is equal to E plus PV. Delta H is equal to delta E plus delta of PV. At constant temperature, product of PV remains constant. Therefore, delta H also becomes 0 in isothermal process. Next question. An ideal gas occupying a volume of 2 decimeters cube and a pressure of 5 bar undergoes isothermal and irreversible expansion against an external pressure of. How to recognize whether the given process is irreversible or reversible? In irreversible process, external pressure remains constant and the difference between the driving force and the opposing force will be large, So that is the way to recognize the irreversible process. In irreversible process, how to get the work done? W is equal to minus P delta V minus P external delta V minus P external delta V. What is the external pressure? 1. What is the external pressure? 1. What is delta V? So it is undergoing expansion from volume of 2 decimeters cubes at a pressure of 5 bars, undergoes isothermal and reversible expansion against a external pressure of 1 bar, and the final volume of the system, and the work done will be equal to, it is 10 decimeter. Because what is the final volume? How to calculate the final volume? P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. Initial volume is 2 decimeter cube, and the pressure is 5, and final pressure is 1, and what will be the final volume? 10 decimeter cube. Now this is the final volume. Now work done is equal to minus P delta V minus external pressure is maintained at 1. What is delta V? 10 minus 2, 8. 10 minus 2, 8 bar liters. Then what will be the work done? 1 bar liter is equal to 100 joules. So work done will be equal to minus 800 joules. Option 3 is the answer. Next, a system absorbs 10 kilojoules of heat at constant volume and its temperature rises from 27 degrees centigrade to 37 degrees centigrade. What is the delta E of the reaction? Delta E is equal to Q plus W. Delta E is equal to Q plus W. Now Q is equal to 10 kilojoules. What will be the work done? Since volume is maintained constant, work done will be 0. At constant volume, work done will be equal to 0. Therefore, delta E is equal to Q, which is equal to, it absorbs means it a positive sign, plus 10 kilojoules. Option 2 is the answer. Next, an ideal gas expands from volume. Here the units are given in MK system. So we can either convert it into CGS system or we can do it directly. In CGS system, 1 into 10 to the power of 5 Newton per meter square is equal to 1 bar. It can be equated to 1 bar. In CGS system, 1 into 10 to the power of, this is the unit in the SI system, which is equivalent to 1 bar in the CGS system, and m cube is equal to 1 meter cube is equal to 1000 liters. Now what is the initial volume? V1 is equal to 1 liter. V2 will be equal to 10 liters, and P external is equal to 1 bar. Therefore, what is the work done? Work done is equal to minus P into 10 minus 1, 9 bar liters minus 9 bar liters. 1 bar liter is equal to 100 joules. So what is the work done? Minus 900 joules. Option 1 is the answer. Next question. So when the external pressure is vacuum, then work done will be 0. When the expansion take place against to the vacuum, then what will be the work done? It will be 0. W will be equal to minus P external delta V. Here P external is 0. Therefore, W is equal to 0. Option 1 is the answer. Next question. Here, what is the point here? Delta H is equal to delta E plus RT delta N. Here 3 moles of the liquid. By undergoing vaporization forms 3 moles of the gas. 3 moles of the gas. Now what is the question? 3 moles of the liquid H2O, say for example 3 moles of the H2O liquid is undergoing a vaporization to give rise to 3 moles of H2O. So delta N is equal to number of moles of the gaseous products minus number of delta N is equal to 3. And what is the RT value? R is equal to, in calories, 2 into 10 to the power minus 3 into what is temperature? 500. So RT value is equal to 1. So RT delta N is equal to 3. RT delta N value is equal to 3. Now what is given for us for 1 mole? This latent heat of vaporization is 10 kilocalories. For 3 moles it will be 30 kilocalories. So delta H is equal to 30 and delta E is plus what is the RT delta N value? 3. So delta E value will be equal to 30 minus 3, 27 kilocalories. Option 1 is the answer. Next. The molar heat capacity of the water at constant pressure C is 25 joules Kelvin mole. When 1 kilojoule of heat is supplied to 100 grams of the water which is free to expand, the increase in the temperature of the water is, so what is the relation between Q is equal to ms delta T? Now what is the question? Delta T is equal to how much? Delta T is equal to Q by ms. What is the value of Q? 1 kilojoule. 1 kilojoule means 1000 joules. What is M? 100 grams. How do you get specific heat? By definition, specific heat is molar capacity by molecular weight. What is this? Cp by M. What is the Cp value? 75. What is M value? 18. So 4.18. So dt is equal to, what is Q? 1000 joules by 100 into 4.18. It comes to 2.41. Option 2 is the answer. So this is simple problem. Next. For a gas having molar mass m, specific at constant pressure is given by definition, specific heat at constant pressure is, by definition, specific at constant temperature, constant pressure is, specific heat at constant pressure is equal to Cp by M. Now CV is equal to, we know that CV is equal to R by gamma minus 1, R by gamma minus 1. Cp by Cv is equal to, Cp by Cv is equal to gamma. Therefore, Cp is equal to Cv into gamma. But what is Cv? R by gamma minus 1. So, gamma, R by gamma minus 1 into gamma. This is Cp value. Now, what is the specific heat? Cp by m, R into gamma by gamma minus 1 by into m. So, before closing, so how we got Cp by Cv is equal to R by gamma minus 1? We know that Cp minus Cv, Cp minus Cv is equal to R. Dividing both sides with Cv, Cp by Cv minus Cv by Cv is equal to R by Cv. Cp by Cv is equal to gamma. Gamma minus 1 is equal to R by Cv, and Cv is equal to R by gamma minus 1. Cp is equal to R into R by R into gamma by gamma minus 1. These are the important relations which we have to remember. So, based on that, the specific heat at constant pressure is that R into gamma by m into gamma minus 1. Option 1 is the answer. These relations are important. Next, molar heat capacity of water in equilibrium with the ice at constant pressure is. So, what is the molar heat capacity? Molar heat capacity is equal to Cp is equal to Q by delta T, Q by delta T. When ice and water are in equilibrium, the equilibrium temperature will be 0. The equilibrium temperature will be 0. So, Cp value becomes infinity. Cp value becomes infinity at 0, because what is the at the temperature maintained at the equilibrium? 0. So, Cp by, how do you get Cp? Heat absorbed by change in temperature, and change in temperature will be maintained constant. Change in temperature will be 0, because ice and water are in equilibrium with each other. When they will be in equilibrium with each other? At 0 degree centigrade. Next, enthalpy of vaporization for entropy change. So, delta S is equal to Q by T. What is Q here? Delta H of vaporization, delta H vaporization by boiling point. What is delta H vaporization? 186.5. What is the boiling point of the water? 373. So, it comes to 0.5. It comes to 0.5. Option 1 is the answer. Next question. Next question. What is the point in a chemical process? What is the delta S? Sum of the entropies of the products, sum of the entropies of the reactants. What is the product here? H2O liquid. For H2O liquid, what is the enthalpy? So, S of H2O minus S naught of H2, S naught of H2 plus half into S naught of O2, half into S naught of O2. What is S naught of H2O? S naught of H2O is 69.9. And what is S naught of H2? 130.6. And what is the S naught? Half into S naught? 102.5. 102.5. So, it must be 70. 130 plus 232 plus minus 70. 230 minus 70, it must be around 160. So option 1 is the answer. Option 1 is the answer. Next. So simple, delta S is equal to delta H by TF. Delta S is equal to delta H by TF. What is delta H? 6 kilojoules, 6000 joules. What is TF? 273. 6000 by 273, it must be around 22. Option 1 is the answer. Next question. So, what is the question given here? 1 mole of ice is converted into water at 273 Kelvin. Entropies of H2S, H2O and H2O liquid or H2S2, H2O liquid. What will be the delta S here? S of H2O liquid minus S of H2O solid. What is the S of H2O? 60.01. 60.01. And what is the this 38.20? 38.20. So it approximately 22 joules delta S. Then what is the relation? Delta S is equal to delta H by TF. Delta H by TF. So delta H is equal to delta S into TF. So delta S is approximately 22 and TF is equal to 273. It comes around 5900. Option 2 is the answer. Next. Melting and boiling point of NaCl respectively are 1080 and 1600 kilo. Delta S for the first and second stage. In the first stage, delta H is equal to what is the answer? What is the delta H value? Delta S is equal to delta H by TF. Delta H by melting point, delta H by TF fusion point. What is delta H? 30. For 30 by 1080, which is equal to 1 by 36 kilojoules per mole for NaCl solid. For NaCl liquid, delta S vaporization. So delta H vaporization by TB. Now what is the answer? In the 160 by 1600, 1 by 10. So it must be option 1 is the answer. Option delta S1 is equal to 1 by 36, delta S is equal to 1 by 10. Next. So what is the delta S? What is the delta S? Delta H vaporization by TB. So what is the definition of the delta H vaporization? Enthalpy change for 1 mole, that is for 18 grams. Here we have taken 900 grams. So for 1 mole delta H is equal to, delta H is equal to 40 kilojoules. 900 grams means 900 grams contain how many moles? 50 moles of water. 50 moles of water. Therefore delta H for 50 moles is equal to 50 into 40. So delta S is equal to 50 into 40 by 373. 50 into 40 by 373, because boiling point of the water is 373. But here how many moles of water is involved? 50 moles. What is, by definition, what is delta H evaporation? Enthalpy change for 1 mole of the water during the evaporation of 1 mole of the water. Because here 50 moles are involved, we have to multiply the delta H value with 50. Next question. For a certain reaction at equilibrium, for a certain reaction, delta H naught and delta S naught are 400 kilojoules and 200 joules per mole. The process is non-spontaneous yet, because delta H naught also appears to be, delta H naught is plus 400 kilojoules. So the process is endothermic process. The process is endothermic process. So we know that according to Le-Chatelier principle, endothermic process is always spontaneous at a higher temperatures, and non-spontaneous at low temperatures. What is the condition for the spontaneous process? Delta G naught, or that is delta H naught minus T delta S naught must be negative. Since delta H takes positive sign here, delta H takes a positive sign here, the process will become spontaneous. The process becomes spontaneous only at high temperatures. At equilibrium, what is the limiting condition for this process? Equilibrium. At equilibrium, delta G naught will be equal to 0. In such case, delta H naught will be equal to T delta S naught, and T will be equal to delta H by delta S. What is delta H? 400 kilojoules, 400 into 10 cube by 200. So 2000 Kelvin. So the process will be spontaneous above this temperature. And non-spontaneous below this temperature. In the given option, the temperature is below 2000 Kelvin in option 3. So in option 3, the process will be non-spontaneous, because delta H is positive. The process becomes spontaneous only at temperatures above that of equilibrium temperature. What is the equilibrium temperature? 2000 Kelvin. That means at this condition, delta G naught will be equal to 0. For the delta G to be negative, the temperature must be greater than 2000 Kelvin. It becomes non-spontaneous if the temperature is below 2000 Kelvin. That is why option 3 is the answer. This model is very, very important. Next. At 27 degrees centigrade, then the value of equilibrium constant. What is the expression for the delta G naught? Minus 2.303 nRT log K. When delta G naught is equal to 0, log K will be equal to 1. Log K is equal to 0. Log K will be equal to 0, implies K value is equal to 1. Option 3 is the answer. Next. The direct conversion of A to B is difficult, hence it is carried by the following paths: A, A to C, A to C, C to D, D to B, D to B. Now what will be the delta S for this process? This is step 1, this is step 2, this is step 3. Step 3. So what is the delta A to B is equal to delta S A to B will be equal to delta S A to C, delta S A to C plus delta S C to D plus delta S D to B, D to B, D to B. What is delta S A to C? 50. What is delta S C to D? C to D 30 units. Here they have not given delta S B to D to B. Instead they have given delta S B to D. So we will take it in a reverse way. Minus 20. So answer is 60 plus 60. Why we have taken minus? In the problem they have given delta S B to D. What will be the delta S D to B? Reverse of delta S B to D. So answer is plus 60. Next. A chamber is divided into 3 compartments, each of volume V as shown in the figure, and each compartment contains same. Since what is this is the simple way. Internal energy is an extensive property, that is it depends upon the quantity, it depends upon the quantity. Therefore internal energy is proportional to the mass. Internal energy is proportional to the mass. What is the mass in the first compartment? W1. What is the mass in the second compartment? 2W1. What is the mass in the third compartment? W1 by 2. What is the ratio? 1 is to 2 is to 1 by 2. It can be reorganized as 2 is to 4 is to 1. 2 is to 4 is to 1. So option 2 is the answer, because it is simple logic. Internal energy is an extensive property. What do you mean by extensive property? The property which depends upon the quantity. So internal energy is directly proportional to the mass. The weight ratio is this. So internal energy is also will be in this ratio. Next question. Next, here also the same question related to the internal energy. Internal energy depends upon both mass as well as the temperature also. As temperature increases, it is a general fact, at high temperatures, because internal energy has 2 components, kinetic energy and potential energy. Due to increase in the temperature, kinetic energy, potential energy both will increase. So internal energy will be maximum at high temperatures and high mass. Internal energy is proportional to both mass as well as the temperature. Both mass as well as the temperature. So mass and temperature are high in the option 3. So option 3 must have the highest value. After option 3, option 1 is in option 1 mass is high, temperature is high. Next come option 3 has the high energy, followed by option 1, and followed by option 2. So it is the option 2 is the answer. So based on this, energy is proportional to the mass as well as the temperature. So mass and temperatures are high in 3, next 1, next 2, next 4. Least is 4. Next, option 2 is the answer here. Next, for the reaction between CO2 and graphite, delta H is equal to plus 170 and delta S is equal to 170 joules. the reaction is spontaneous at what temperatures? Graphite and this thing. Delta H is spontaneous at what temperatures? Because delta H is a positive. Delta H is a positive. So T will be equal to, at equilibrium, delta H by delta S. Because what is the point here? What is the condition for the spontaneity? Delta G is equal to delta H minus T delta S should be negative. At equilibrium, delta G will be equal to 0. So T is equal to delta H by delta S. T is equal to delta H by delta S. This is plus 170 and this is 170. So temperature at equilibrium, the temperature will be 1000 Kelvin. Since delta H is positive, so the process can be spontaneous only when the temperature is maintained higher than the 1000 Kelvin. So option 4 is the answer. The process becomes spontaneous at temperatures higher than the 1000 Kelvin, because mind that if the process is endothermic, delta H takes a positive sign. When delta H takes positive sign, delta G can be negative only at high temperatures. So this process becomes spontaneous at temperatures above 1000 Kelvin. So above 1000 Kelvin is in option 4. So option 4 is the answer. Next. Now what is the delta G naught for the process means? So we have to, delta G naught for the process is delta G naught of Cu plus 2, delta G naught of Cu plus 2 minus delta G naught of Cu plus. Delta G naught for the process is given by delta G naught of Cu plus 2 minus delta G naught of Cu plus. For Cu plus 2, delta G naught is equal to, delta G naught of Cu plus 2 is equal to delta H naught. What is delta H naught? 64.7 kilojoules, 64,700 joules. Delta H. What is the T? 298, because at standard conditions the temperature is 298 into minus 99 and delta G naught for Cu plus, delta G naught for Cu plus, this comes around 94 kilojoules. This comes around 94, approximately this value is 94 kilojoules. And delta G naught for Cu plus is given by 71 700 and minus 298 into 40, this comes around 60 kilojoules, approximately it comes around 60 kilojoules. So delta G naught for this process will be equal to 94 minus 60, approximately it will be equal to 34 kilojoules. So option 2, it is plus 34.42. Option 3 is the answer. Next. So delta H naught and delta S naught are given. The process can be spontaneous. Simple logic is delta S, T will be equal to delta H naught by delta S naught, so plus 284 into 10 to the power of 3 by 68. So it must be around 4,000. The process can be spontaneous because delta H is positive. The process can be spontaneous above the temperature. If the temperature is maintained greater than 4000 Kelvin. Had it been exothermic process, the process will be spontaneous at temperatures less than 4000 Kelvin. Since the process is endothermic, the process can be spontaneous at temperatures greater than 4000 Kelvin. Had it been exothermic process, the process will be spontaneous at temperatures less than 4000 Kelvin. So option 3 is the answer. Next question. This is in this case, what is the delta G naught? Delta G naught is equal to minus NF E naught, minus NF E naught. Simple logic is minus NF E naught, minus NF E naught. What is the E naught value? What is the E naught value? In this case, E naught of this cell is equal to, in this cell, iron will act as the cathode and zinc will act as the anode. E naught of the cell is equal to minus 0.46 minus 0.76. It is 0.30 volts. 0.330 volts. Now what is the N value here? 2. So delta G naught is equal to minus 2 into 96,500 into minus 330 volts. So option, it comes to 6 and 96. It must be around 5 lakhs something, 57.9 joules, kilojoules. Next, 1 gram of H2 gas at STP expanded so that its volume is doubled. Hence work done is, in this problem the answers are given in 2 units. One is kilocalories, kilojoules and liter atmospheres. What is the point? 1 gram of the hydrogen at STP can occupy 11.2 liters. Volume gets doubled means, what is the work done? Minus P external, V2 minus V1. What is the external pressure? 1 atmosphere. It is 22.4. It is 11.2. Because 1 gram of the hydrogen can initially occupy 11.2. Since volume gets doubled, it is 11.2 liters atmospheres. When it is converted into joules, 11.2 into 1013 joules. So it can be option 1 and 3 and 4. Next, if a gas absorbs 200 joules of heat, and then what is this is direct application of the first law of thermodynamics. Delta E is equal to Q plus W. What is Q here? Absorbed 200 joules. What is W? It's a work of an expansion. P delta V. What is delta V? 500 cc means half liter, and 2 into 10 to the power of 5. Now what is P external? 2 into 10 to the power of 5 newtons per meter square. In CGS units, it will be equal to 2 bar. And delta V is equal to 0.5 liters. So work done is equal to 2 into 0.5, 1 bar liter, that is equal to 100 joules. 100 joules. So option can be in calories, it is 23.92 and 100 joules. Work is done by the, then total change in the internal energy. So W is equal to minus 100 joules. What is delta E value? 200 minus 100 joules. This is also equal to 23.92 calories. So option 1 and 3 is the answer. Next, here the expression for the delta S, here two parameters are getting changed. What are the two parameters that are getting changed? Both temperatures and the pressure are changing. So what is the expression for the delta S? What is the expression for delta S at what is the expression for the delta S? NCV 2.303 log T2 by T1 log T, NCP, because pressure is changing here. NCP 2.303 log T2 by T1 plus NR 2.303 log P1 by P2 log P1 by P2. What is the N value here? 3. What is the N value here? 3. For a diatomic gas, what will be the Cp value? 7 by 2 or 7 by 2 or means 7 by 2 into 2.303 log, what is T2? 596 by 298 plus NR plus 3 into 2.303 log P1, what is P1? 1 by 4. So simplifying it, we get the answer as 6.3 calories. Option 4 is the answer. Next, two moles of an ideal gas is expanded irreversibly and isothermally at 37 degrees centigrade until its volume is doubled and 3.41 kilojoules of heat is absorbed from the surroundings. What will be the? Thank you very much. We'll continue. 2 moles of an ideal gas is expanded irreversibly and isothermally at 37 degrees centigrade until its volume is doubled and 3.41 kilojoules of heat is absorbed from surroundings. What is the delta S total? What is the delta S total is equal to delta S of this system plus delta S of the surroundings. So delta S of the system because volume gets delta S of the system is equal to 2.303 NR NCV NR 2.303 log V2 by V1 log V2 by V1 and delta S of the surroundings is because minus delta H of the surroundings by temperature, because surrounding has lost heat to this time. So minus Q by T. What is the amount of heat lost by the surroundings? 3.41 kilojoules. So minus by what is the temperature? 310. Here what is the point? 2 into what is the R value? 8.314 into 10 to the power of minus 3 into 2.303 log, since volume got doubled, log 2. So adding both will get the answer. It must be 0.52. It must be 0.52. This is the delta S of the system. This is the delta S of the surroundings, because surrounding has lost heat to the system. So minus Q by T. Why we have taken minus Q? Because it has lost the system. Next. We will continue in the next class. Thank you very much.